All right, you guys. So our final section in this unit, we're going to be talking about the converse theorems of the theorems we've already been talking about, which a converse is when we reverse a statement. So if you guys remember when we did proofs in the previous section, we were given that lines are parallel. And if we know lines are parallel, then we can assume all of those parallel line angle properties. So we know alternate interior angles are congruent. We know same side interior angles are supplementary. We know corresponding angles are congruent. We know alternate exterior angles are congruent. So now we're reversing this. So this time we're trying to prove lines are parallel. So before we were given lines are parallel, now we're going to be proving lines are parallel. Guys, so if we don't know lines are parallel, you cannot assume any of those angle pairs are congruent or supplementary. Okay, that only happens when lines are parallel. But if we can show that those angle pair properties exist, it means lines are parallel. Like, for example, if we can show that corresponding angles are congruent, that means your lines are parallel. And since we're reversing the statement, this will be the converse of the corresponding angle postulate. Okay, if we can show that alternate interior angles are congruent, then by the converse of the alternate interior angle theorem, your lines are parallel. Pretty cool, right? All right, if we can show that same side interior angles are supplementary, that also means lines are parallel by the converse of the same side interior angle theorem. And lastly, if we can show that alternate exterior angles are congruent, then your lines are parallel by the converse of the alternate exterior angle theorem. All right, so basically in order to show lines are parallel, we have to show that one of these angle pairs exist and that their properties hold. And if that's the case, then lines are parallel by one of these converse theorems. So that will be the key in our problem. So our example one, you can go ahead and copy down example one. This is how it looks. But I'm going to go ahead and get started, which I have it copied down on this paper. So there you go. All right, so example one, we are given that angle 4 is congruent to angle 6. So I'm going to go ahead and mark my picture. It's always good to mark your picture if you can. Okay, and I'm trying to prove that lines are parallel. So I cannot use any of those original theorems we talked about. I can't use alternate interior angle theorem, corresponding angle theorem, alternate exterior angle theorem, or same side interior angle theorem because I don't know lines are parallel. Okay? Now, if you see, we are trying to prove lines are parallel. Whenever we are trying to prove lines are parallel, that means a converse theorem is lurking in the midst. Okay, so for my final statement, when I say the lines are parallel, my reason has to be one of the converse theorems. So I need to show that some of those angle pairs are true to prove lines are parallel. Now, I was given that angle 4 and 6 are congruent, okay? Which if I trace over these angles, what letter forms? Oh man, the Z forms. So I'm given that alternate interior angles are congruent. Okay, so since I'm given that alternate interior angles are congruent, that means we are proving the converse of the alternate interior angle theorem, which means I cannot use that theorem. Okay, so I can't be like, oh, well, lines are parallel because alternate interior angles are congruent. I'm done. Look at that. Nope. Sorry, you cannot use the theorem that you're trying to prove within the proof. Okay, so I have to show that one of those other angle pairs, one of those properties will hold. And if I can, then lines are parallel. So I'm going to have to use angle 2 somehow to maybe show that one of those other angle pairs are congruent or supplementary. I don't know. We'll see. Okay, let's get started, you guys. So, we always start with, let's say it together, 1, 2, 3. The given! Yay, we said it at the same time. That was really cool. Whoa, cool beans. Okay, so we're given angle 4 is congruent to angle 6, and this is by the given. All right, so I need to find a way to incorporate angle 2 to maybe eventually show that one of those nifty angle pairs is either congruent or supplementary. So do you spot any ways that I can bring angle 2 into this picture. Do you see a way it either will relate to angle 4 or angle 6? I see it too, guys. Whoa. Do you guys see, I'm going to use yellow. Do you guys see the X? Whoa, holy hot dog, right? Which angles form at the X? They are vertical angles. So I know that angle 4 and angle 2 are vertical angles, which might be helpful when I'm solving the problem. I don't know though. We'll have to see. Okay, so I know angle 4 and angle 2 are vertical angles. I ran out of space. Sorry, guys. Angle 4 and 2 are vertical angles. And how I know that is, well, vertical angles form when two lines intersect and are right across from each other at the X. So that is what it means to be a vertical angle. So this would be your definition of a vertical angle. Definition of vertical angles. And now that I have declared that those are vertical angles, now that I know they're vertical, how do vertical angles relate to each other? Yes, that is correct, like normal, you guys. You are super smart. Guys, so I know angle 4 is congruent to angle 2. And how do I know that? What definition, theorem, or postulate tells me that vertical angles are congruent? Precisely, you guys. That would be the vertical angle theorem. Vertical angle theorem. Nice job. Okay, so if you guys see here, I now have two congruent statements. Maybe if I can use these two statements to show that one of those nifty angle pairs, since I have congruent symbols, are congruent, if I can show some of those angles are congruent, that would mean lines are parallel. So let's see what will happen. Okay, if you see here, I know I'm going to use these two. Okay, I know 4 is congruent to 6, and 4 is congruent to 2. Okay, so based on these statements, can I assume anything else is congruent if 6 is congruent to 4 and 4 is congruent to 2? Okay, well, if 6 is congruent to 4 and 4 is congruent to 2, guess what, you guys? That means angle 6 is congruent to angle 2, and it has that nice rhythm, that nice flow to it. So if 6 is congruent to 4 and 4 is congruent to 4 is congruent to 2, then 6 and 2 have to be congruent. And that would be because the transitive property. Transitive property. Also, you guys, since, let's see here. Since 4 is congruent to 2, I could technically replace this 4 with a 2. I could slide this thing right there. All right, and then I could say 2 and 6 are congruent. So I could also use the substitution property. So whatever floats your boat. All right, so I have shown now that 2 and 6 are congruent. So maybe, I don't know, maybe 2 and 6 are one of those nifty angle pairs. And if so, I showed they're congruent, which if it's one of the angles that are supposed to be congruent, that would mean lines are parallel. So let's see here. When I trace over 2 and 6, what letter do we see? So here's angle 2, and here's angle 6. What letter is forming when I trace over angle 2 and angle 6? Do you guys see it? It's kind of like an F shape. Do you guys see it? In this case, it's like a backwards F. Whoa. Which types of angles make the F shape? Yes. Yet again, you guys are correct. Corresponding angles make the F shape. So I have proven that corresponding angles are congruent, which will tell me then that my lines have to be parallel. So before I say my lines are parallel, though, I'm going to say that angle 6 and angle 2 are corresponding. They are corresponding angles. And how I know that is because they're located in the correct spot for corresponding angles, or they make the F shape. So this would be by the definition of corresponding angles. Definition of corresponding angles. All right, you guys, we have reached our final step by using these two lines. Okay, so I've shown that 6 and 2 are congruent. And 6 and 2 are corresponding. So if we go back to our nifty PowerPoints, if we look here, okay, by the converse of the corresponding angles, if two lines cut by a transversal form corresponding angles that are congruent, then that means your lines are parallel. Okay, so since I have proven that corresponding angles are in fact congruent, that has to mean that line L is parallel to N. And anytime you are proving lines are parallel, I should see a converse theorem in the statement or in the reason. This should have a converse with it. It will always happen. Okay, so if your lines are parallel, you should be using a converse theorem. So I prove corresponding angles are congruent. So by the converse of the corresponding angle theorem, my lines are now parallel. Actually, it's postulate, but that's kind of really nitpicky. But technically, it is the corresponding angle postulate, but yes. Oh man, wasn't that cool, you guys? So if you're ever proving lines are parallel, I must see the word converse in this statement. It must happen. And guess what, you guys? We have reached what we're trying to prove. So nice job. We're super excited. Way to go, you guys.